All right, so before you start your warm-up, here's a quick review of what we talked about on Thursday and Friday, which was what 6-4 was broken down in between. Okay, the first thing was the dot product. So how do I find the dot product of two vectors? Okay, first one times first, right? Second times second, right? So if I have U1, U2, and I have V1, V2, then the dot product is going to be the first times the first. Oops, not in brackets. First times first plus second. Get my U's to look different than my V's. Second times second. So at the end, you're going to end up with just one number, okay? Then we talked about finding the angle between two vectors. So the cosine of theta would equal the dot product of those two vectors over the magnitudes multiplied together. So magnitude of U times magnitude of V. And then on Friday, we talked about the relationship between two vectors, if they were orthogonal or if they were parallel or neither. How would you know if they're orthogonal? What's the dot product? Zero, right? So if the dot product of those two vectors is zero, then they're orthogonal. And if not, they could also be parallel. So if you compare their two slopes and they were the same, they could also be parallel. Or they could be neither. So on this warm-up, it's just asking if they're orthogonal. So you just have to look at the dot product. All right, so number one just says to find the dot product of these two. I'm going to take the first, which is 7, times the first, which is 2, plus the second, which is -3, times the second, which is 8. And I get 14 minus 24, which is -10. Good on that one. Yep. Okay, second one says angle between U and V. So I've already got the dot product, but just as a reminder, I'm doing cosine -1 of the dot product over the magnitude of U times the magnitude of V. So I've already got the dot product, which is -10. And then I need to find, God bless you, the magnitude of U, which is the square root of 7 squared plus -3 squared, or square root of 58. And then I need to find the the magnitude of V, which is square root of 2 squared, or 4, plus 8 squared, which is 64. This is square root of 68. So when you go to type that in the calculator, you want to make sure that you group together your denominator. You can actually keep them both underneath the square root, but you want to make sure that they are they're being multiplied together. And then also, what mode do you want your calculator to be? Degrees. So second cosine, -10 divided by square root of 58 times 68. And you should get 99.16. So I'm going to round it to 2 decimal places for now. Okay, test will tell you, so pay attention. And it flip-flops. Sometimes it's nearest 10, sometimes it's hundredths, sometimes whole number, whatever it is. Make sure you're paying attention. And just like we just did, you're going to have the calculator the whole time on your test. Some of your answers are going to be asked to be kept exact, and then some of them will be rounded. Obviously, if it's rounded, you need to round it. And if it's kept exact, then you would not be rounding it. So these would be things like unit circle related or magnitudes that you can square root and simplify but not get a decimal. So then the last question just says determine if they're orthogonal. And remember, it's if the dot product is 0, which it's not. So this would be no. You could also get asked if it's that or parallel or neither. So let's say I wanted to see if these two are parallel. I would just get their slopes by doing -3/7 and 8/2. And this one reduces to 4/1. These are definitely not the same. So this is a case where they'd be neither. Questions? My other recommendation was to make sure that you graph this to see if this angle makes sense. So if I was to just roughly graph 7, -3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, that'd be the first vector. And then the second one, 2, 8, 2, 1, 2, 3, 4, 5, 6, 7, 8 would be all the way up here. That'd be your second vector, which definitely appears to be obtuse, a little bit bigger than 90 degrees, which matches our 99.16. Okay, make sure you take an extra second to graph it so that you make sure that you know that it's correct. And that also, like if I was looking to see if that was orthogonal, that is close to 90 degrees, which would make it perpendicular, which would make that the case. But it's not. We know it's 99, so and then the fact that the dot product is not 0 kind of confirms that. All right, questions of the warm-up? Questions on homework from either section of 6.4 homework? Okay, so we're going to move into 6.5. So the good news is it's short and it's easy. And it's the last section that we're going to cover in the chapter. So 6.5 is called trig form of complex numbers. So we're going to learn how to convert from trig form to complex or complex to trig form. Okay, if you remember complex, do you remember what makes a number complex? Been a couple chapters. I'll give you a hint. It's an imaginary number. Do you know an imaginary number? What is the imaginary number that we know? I. So if a term has I in it that's complex, it would be A plus BI. And if it's trig form, you'll see in just a moment how you can identify that. Okay, so if it has the I in it, not like IJ, because that's a different I. Super confusing, but that's a different I. Okay, this is I in terms of imaginary number. So the first thing we're going to learn how to do is graph them. Okay, on a complex number plane or coordinate plane, which appears to be much like an x-axis and a y-axis. The x-axis is called your real axis, and the y-axis is your imaginary axis. So you can actually take something that's in coordinate form, like 2 plus 3i, and convert that into coordinate grid, like 2, 3, and then you'd go over 2, up 3, and you'd plot your point here. This is a point, not a vector, so it's a single point. There's no line connecting that. Sometimes you'll see it with like a dashed line, but it's not an actual solid line. And positive, negative obviously stays with the number, so if that was 2 minus 3i, then I'd be going down to the right 2 and down 3. So that's the first thing you do, plot your point. Then you could be asked to find the absolute value of a complex number. So the absolute value is actually the distance between the origin and point AB. So if I use the same 1, 2, 3, 1, 2, 3, then it's saying that the absolute value is actually this distance. Does that look familiar? Does this look familiar? What else do we use that for? Magnitude. So magnitude is now the same as distance. You're going to see in a moment it's the same as radius. It's all the same thing, right? If I have a coordinate point that is 2, 3, and I move to the right 2, and I move up 3, I'm making a right triangle. If I wanted to find that other missing side, the radius, the distance, the absolute value, all of that same thing, then I could use the Pythagorean theorem to say that 2 squared plus 3 squared equals the square root, or equals the missing side squared, and you'd solve it by doing the square root of a squared plus b squared. So they all now mean the same thing. That's the good thing, is you're seeing it a lot of times, right? You're seeing this for magnitude, you're seeing this for distance, you're seeing this for the radius, you're seeing this now for the absolute value of a complex number. This would be an example of things to be kept exact. So if I go to find the square root in square root 20, let's say, then my answer is 2 root 5. I would not use a calculator to round that. It will, unless it says to round it, you're keeping it exact. All right, so it says plot and find the absolute value. So we're going to plot z. I'll do the first one with you, and then you can do the second one. Negative 3, 6i. So I'm going back 3 and up 1, 2, 3, 4, 5, 6. This would be negative 3 plus 6i. And then to find the absolute value, this is my A, and the B is just the 6. It has nothing to do with the I. It's attached to it, but it's not actually B. So I do the square root of negative 3 squared plus 6 squared, and I get the square root of 9 plus 36, square root of 45, and I know that to be 5 and 9, which is 3 and 3. So this is 3 root 5. So again, unless it says to round it, you'll keep it as its exact form, which would be 3 root 5. All right, you do B. All right, B, so it was right 2, down 4. The negative stays with the 4. Plots it in the fourth quadrant. And then square root of 2 squared plus negative 4 squared is 4 plus 16 squared of 20, which is 2 root 5. Easy stuff, right? Okay, good. All right, then the next thing we're going to learn how to do is get from complex number to trig form, or check it using complex to trig. So the trig form of a complex number, and this is our complex, right? So complex has the I, the A plus BI. Okay, that's complex. To find the trig form, we're going to take R, and R comes from the absolute value, or the radius, or the distance. All that's the same thing. You're going to first find R, which is the square root of A squared plus B squared. And then we're going to put it in parentheses next to cosine of theta plus I times the sine of theta. And then you'll find theta. So because we can create with those side lengths a right triangle, and we'd know the opposite side and we'd know the adjacent side, we can actually use tangent. So if the tangent of theta is B over A, then we will look for the tangent -1 of whatever B over A is. And for your test purposes, and for I think all of the homework, it's going to be a unit circle angle. If it wasn't, then you'd use your calculator. If it's a unit circle angle, you need to know it without your calculator because it will be kept exact. So if you could picture what we just did before, like if we had 2 plus 3i, and this goes right 2 and up 3, this would be my coordinate point. You can actually draw yourself a little triangle. This was 2, this is 3, okay? So this would be an example that's not on my unit circle, because if I wanted to find theta here, I would say that the tangent of theta equals 3 over 2, and then I'd have to find the inverse of 3 over 2 to give you tangent, which has an answer. Okay, tangent can be bigger than 1, but it won't be on my unit circle. Does that make sense? And then the other thing I'd need to know is what this is, which is the absolute value, the radius, the magnitude, all that's the same kind of thing, which would be 2 squared plus 3 squared. All right, let's work through an example. So it says write the complex number in trig form. My advice, first thing, draw yourself a little graph and identify where it is, okay? So 3i is really missing my a component, right? Which would make my a what? 0. This would be 0 plus 3i. In point form, it'd be 0, 3. So I'm not going right or left at all, but I'm going up 1, 2, 3. So this point actually falls right on my y-axis. So let's say we didn't know to count, right? The first thing I want to find is what R is. So R is the square root of A squared plus B squared, which is 0 squared plus 3 squared this time. Square root of 9, which is 3. That's my R, which makes sense. If I count 1, 2, 3, that's how far up this went. That's the distance from 0, 0 to my point. And then the second thing I need to find is theta. So the tangent of theta is B over A, which in this case is 3 over 0. What's 3 divided by 0? Undefined. So think about your unit circle and your tangents, okay? If we just did first quadrant, quick reminder. If it's 0, the tangent is 0. If it's pi over 6, the tangent is root 3 over 3. If it's pi over 4, the tangent is 1. If it's pi over 3, the tangent is root 3. And if it's pi over 2, my tangent is undefined. And that pattern completes as I go all the way around the circle. We're not gonna restrict it this time. We're gonna use our full circle. So if you knew that tangent was undefined, then theta is going to equal tangent -1 of undefined. And this is not something you can type in your calculator, right? You can't type undefined in there. So you've got to know your unit circle angles. So where on my unit circle is tangent undefined? Pi over 2. And technically also 3 pi over 2, right? So there's usually going to be 2 options, okay? And then you have to use your initially plotted point to narrow down which one it is. So if it could have been at pi over 2, it could have been at 3 pi over 2, but I know my initial plotted point is here. That tells you which angle are we using. What's at the top? Pi over 2. Does that make sense? So if this point was -3i, my radius would be the same, but I'd either get pi over 2 or negative or 3 pi over 2, and that time you'd have to know to use 3 pi over 2. So you're going to plot your initial point, or at least visualize it, figure out which of your, because you're going to have 2 choices almost every single time. Figure out which one it is. So I know theta is pi over 2. Now I plug it in. So it's r times cosine of theta plus I sine of theta. R is 3. Cosine of pi over 2 plus I sine pi over 2. That is trig form of this complex number. So we need R, and we need theta, and then we plug it in. Now the best part of these are easy to check, right? So like if I wanted to work backwards and I wanted to say, okay, 3 times the cosine at pi over 2. So what's cosine at pi over 2?
0.
Plus I times the sine at pi over 2. What's the sine at pi over 2? 1. So then I can distribute, right? 3 times 0 is 0 plus 3 times I times 1 is 3I. And I'm back to my initial question. So these are easy to check. I'll tell you right now, God bless you, the ones on your test are going to be unit circle based, so they will kept exact. Questions so far? Okay, try the next one. See how far you can get. All right, so negative 2 minus 2i would be negative 2 in coordinate point form, right? So I'm going to go back 2, I'm going to go down 2. That's what this point should look like. Already that tells me that my answer should be from my third quadrant when I'm looking for my angle, okay? The radius, or the distance from 0, 0 to this point would be the square root of negative 2 squared plus negative 2 squared. And I get square root of 4 plus 4, which is square root 8. I'm going to reduce that to be 2 root 2. So that's my r. And then to find theta, I would say the tangent of theta is b over a, so negative 2 over negative 2. And I end up with the tangent of theta is a positive 1. So you're looking for where on your unit circle your tangent is a positive 1. So we already talked about, remember, there's going to be 2 choices, right? The over 4s give you the 1s. Tangent's positive in the first quadrant and in the third quadrant. So I'd either have pi over 4 or I'd have 5 pi over 4. But we said, where is this point lying? Third quadrant, which means my theta is 5 pi over 4. So then I would plug it in. Z would equal r, which is 2 root 2, times the cosine of 5 pi over 4, plus I, and don't forget it because a lot of people do. Don't leave out that I. Sine of 5 pi over 4. And then again, easy to check. So that's my answer. Okay. But easy to check because I could say that 2 root 2 times the cosine of 5 pi over 4, cosine there is negative root 2 over 2, plus I times the sine at 5 pi over 4, also negative root 2 over 2. And then distribute that in, I'd get 2 root 2 times negative root 2 over 2, plus I times 2 root 2 times negative root 2 over 2. These cancel. Root 2 times root 2 is 2. That's just negative 2. Plus the root 2 and the root 2 give you 2. The 2's cancel, and I get negative 2i. So negative 2 minus 2i matches what my original question was. Okay, these are easy to check. If you've got the extra minute or so, do it. If you had accidentally grabbed that to be pi over 4 instead of 5 pi over 4, your answer would be 2 plus 2i. So hopefully you can catch it, like it would be the same terms but the wrong signs. All right, questions on anything 6-5 related, okay? That wraps up the chapter. So we'll start reviewing for your test tomorrow.